Today we're going to be talking about how to create a training run in Chariot. To create a training run, navigate to your project's Training Runs tab, like I've done. Then select Start New Run. After selecting Start New Run, you'll be given the option of choosing among 3 different wizards. We'll be covering the Quick Start and Full Configuration wizards in this video today. The third wizard, Advanced Configuration, is available if you want fine-grained control or if you are providing a custom blueprint. I'm selecting the Quick Start wizard first. I select Quick Start and then press Next. I must give the training run a name, a version, and then select the task type. I'll call this Test Detection. For the version, we can leave it as 1.0. We have an image dataset, and we want to train it for an object detection task, so we'll select that. We then press Next. We must then add training data and validation data from existing snapshots. I want to use the XU EO Vessels dataset, and I select its pre-created train split. Chariot lets me know that I can add validation split from the same dataset, and it saves me time by allowing me to just select that automatically. I then select which labels I want to train on. The Quick Start wizard has selected all of them, and I'm happy with that selection, so I'll click Next. On the next screen, we're given the option of choosing an architecture. We can either start from scratch or fine-tune from a previously trained model. In this case, I'm happy with the selection YOLO V8 Small for my architecture. We then have options like batch size, the number of epochs to train for. I think 10 is a little small since this dataset is quite small, so I'll switch this to 100. We then have to allocate our compute resources. Normally, you want to select some type of GPU if you're training a computer vision model. This cluster has Tesla T4s and Tesla V100s. I'm going to select the Tesla T4, and I'm happy with the other resource requests, so I'll just select Next. The review screen gives me the option to review my selection. I'm happy with these options, so I'll submit the training. Now that the training run has been submitted, it's going to begin a startup sequence before it can begin training. If I want to monitor this, I can go over to the Events tab. As you can see, the most recent event is the cluster telling us that it's scaling up resources. I'm going to let this continue while we walk through the other wizard, and then we'll return to this. I'm going to go back to the Training Runs tab, start a new run, and walk you through the Full Configuration wizard. After selecting Full Configuration, I click Next. I'm training for images, and I must now give this a new name. I'm going to call this Test Full Configuration Detection. I'm happy with the 0.1 version number, and I need to select the object detection task type, like we did earlier. I'm going to add the same training dataset we were using before. I want to use the train split. And I can go in and select the val split. With my data selected, I scroll down and see the batch sizes. I'm happy with those, so I'll leave them unchanged. Once again, I have to select the labels. I'm happy with the selected labels and the include negative samples toggle, so I'm going to leave that as it is, and then proceed to the next. This is where we start to see some departure from the Quick Start wizard. The number of architectures I can choose from in full configuration is much larger. For example, I can choose a different size YOLO model. I'm going to choose the medium, since we chose the small before. Let's then specify an image resize. I also have the option to select augmentation parameters. If I want, I can select a random crop. This is useful when I have large images and I want to take a random subset of them. In this case, I'll turn on random crop and have it match my resize. I can also apply data augmentations. Data augmentations are roughly split into two groups. There are those that modify the colors of the underlying image and those that don't. In this case, since I have color imagery, I don't mind having the color transformations. I think 5 data augmentations is probably a little too many, so I'll bring that down just a little bit, 3. I'm happy with the transformation strength. I can also apply gradient clipping. I won't right now, but it is an available option. Then I see my training settings. This includes things like optimizer settings and more advanced control over augmentations. For example, down here I could choose which augmentations I want to include. I can also specify the use of a linear stretch or clade. I can also fine-tune the optimizer settings if I'm unhappy with the default optimizer settings. In this case, I am happy, and I'll proceed to the next screen. Finally, we have to select the resources again. I'll select the Tesla T4 and submit the job. Let's go back and look at our training run from earlier. As you can see, it started training. Let's look at it. Scrolling back to the Events tab, we can see that most recently the job started running after pulling the relevant images. We can see what's happening on the container running our job by going over to the logs and selecting the container logs. We can see ongoing metrics by going to the Metrics tab, and in this case, we can look at the training logs. Let's look at this in a run that's already completed. This training loss is a little noisy, so maybe we could apply some smoothing to it. We can also set access limits or only show the values at checkpoints. There, that's much easier to read. I'm going to clear my settings. Let's look at some validation statistics. When our run reaches a checkpoint, it's going to do some evaluations. We can look at the mean average precision for this training run on its test set. As you can see with this run, the mean average precision increased steadily over the course of the run. This is what we would expect. The run will also output a set of checkpoints, which we can later catalog as models. We also have the option to clone an existing training run or copy its config. This is useful if we want to kick off a bunch of runs that are very similar to each other. This covers training runs inside of Chariot.